I'm Daniel Kelleher, and I'm an engineering lead at Civic.com, and I'm going to talk about identity.com, our open source decentralized identity ecosystem. So a couple of things to clear up first. I'm kind of a stand-in for our main self-sovereign identity guy, Martin Riedel, who's escaped and left me to talk about this. So what I'm going to do is, if you guys have questions afterwards and I don't know the answer, I'm probably not going to make something up. I'm going to defer you to him. Secondly, why am I from Civic and talking about identity.com? That's something that's not always obvious. So Civic is basically the kind of, you could imagine it as the application layer on top of the self-sovereign and decentralized and open source identity.com layer. We're driving use of this ecosystem, and we're providing the kind of the business value on top, you could argue. Thirdly, that's a big word, or big set of words. I'm going to talk about the last one mostly, ecosystem. What does that really mean? Well, you can think of the identity ecosystem, the identity space, as being made up of a bunch of actors, a bunch of roles. The W3C calls them identity verifiers, subjects/holders, and issuers. In identity.com, we have some slightly different names for them at the moment, anyway. And then the other part of an ecosystem is, of course, the relationships between these roles, the protocols that govern how they communicate. So what I'm going to talk about is how the ecosystem is manifested in identity.com, what identity.com provides. Specifically, it provides a set of toolkits to allow actors in the identity space, who, by the way, very few people come into the identity space saying, I'm going to be an actor in the identity space, right? They have another job they're trying to do, and they need to interact with the concept of identity. So they assume these roles. And then, we provide toolkits to help them implement this and implement the protocols, the communication mechanisms between the different roles, without really having to do much else, without having to think about it. And these protocols, where these protocols are standardized, for example, with DIDs and verifiable credentials, we use those. And where there's no standards yet, we're working with organizations like Rebooting Web of Trust, like W3C, in order to establish those protocols, those standards, and integrate them into identity.com. Okay, so quickly the three roles, what they mean. So I'm going to oscillate between the kind of the identity.com naming scheme and the W3C one, because I can't keep it in my head very easily, but I hope you can follow along. On the left-hand side, we have identity verifiers. These are your service providers, businesses that are trying to sell something, services that a user is trying to gain access to, a vending machine, a point of sale that requires some form of KYC in order to issue a product or something like that. And they tend to, let me talk on the next slide actually. So they have a number of jobs they want to fulfill in the identity space. The first one is generating a presentation request. I'm not sure really of the kind of the level of the familiarity with all the jargon here. So I'm going to probably describe a few things a little bit, but not too much. So a requester or an identity verifier will have a list of things they need to know from the subject, and that's the presentation request. Once they receive a response to that request, by the way, in identity.com we call those dynamic scope requests, DSRs, at the moment. Once the requester receives the response, they need to verify that that response is correct, usually through some cryptographic proof. And then in identity.com, there's also this concept of the marketplace that I'm going to mostly gloss over for the purposes of keeping things brief in this talk. But there's this concept of the requester then paying for having received that verified information. So on the other side of the bus, there is the identity issuer in W3C speak. In identity.com, we call them validators. And they are the ones that provide verifiable credentials. So they have to collect information, typically from the subject. And this is where I think identity.com plays a really important role, by the way. They collect that information from the subject in some form. They verify that information is correct. They may not actually have to collect anything. They may have this information. If it's a government, they typically have records, right? and then they issue a verifiable credential and sign it in some way, attest to it in some way. And they can also revoke that. And again, on the marketplace side of things in identity.com, there's a way of making yourself discoverable. We use public DIDs for this, and setting prices and things like that. Finally, there's the person or entity that the whole thing is about, the subject, and not necessarily the same person as the holder, but for the moment, for this purpose of this talk, I'm going to assume it's a person, which is a generalization, and assume that the subject and the holder of the information are the same person, which is another generalization. And for them, we provide a Credential Wallet. It's, again, something that can be integrated into a wider app or a web app or something you download or install, you carry it on your phone or whatever. And its role is to match the presentation request that comes from the requester to the credentials that you hold in your wallet. So if you've just installed this Identity Wallet app, let's say, you don't have any credentials, right? Nobody knows who you are. You don't know who you are, let's say. You get a presentation request that comes in, and then the Credential Wallet will know to go to the marketplace and find a validator that's capable of resolving that, that's capable of issuing a credential that will resolve that presentation request. Let's say you go through that process with the validator, which I'll talk about more soon. Then you do something called Selective Disclosure, or issuing a proof, which is basically providing the information in the presentation request to the requester. Selective disclosure is very important, by the way. The requester may only want to know that your date of birth, or they might even need to know that you are over 18, for example. And you have a credential saying everything about yourself. You don't issue that entire credential. That's what typically happens right now, right? In a non-self-sovereign identity world, you have to send people your passport or your ID card. With a self-sovereign solution and verifiable credentials and things like zero-knowledge proofs, you can only provide the information that the requester needs. It's good for everybody, good for the requester because they have fewer regulatory requirements. And you also can do so in a verifiable way, in a provable way. You're not just asking the requester to believe you when you say you're over 18. You have a mathematically or cryptographically verifiable proof of that information. And so the next part is the bit that I think is really interesting, the interactive validation with the Id Validator. And I think we have a demo for that. And I have to just figure out how to bring it up on PowerPoint, so 1 second. I think if I click here, then it will bring up another window somewhere else. I've got the window here, I'm just going to bring it over. Yeah. All right. So before I start it, what you're seeing is an implementation. That's why it's got the Civic logo on it. Now we're kind of from the point of view of an application layer on top of identity.com. And what we've got is a payments app. You can think of it as kind of like a wallet / PayPal sort of situation. And it embeds inside it the Credential Wallet. That's one way of implementing all this stuff, one of many possible ways. The advantage of this is that the user doesn't have to have a separate identity wallet that some people like, some people don't like. We also have an identity wallet. But it's important to bear in mind when you're looking at this. I'll let it run in a second, and then I'll talk about it afterwards, because it's much easier once you've got some context. But what's happening is the Civic Pay app is taking the role of the requester, or the verifier of the identity information. And it's communicating behind the scenes with the Credential Wallet that's inside it, which is communicating through identity.com with a validator that is collecting the information, providing a verifiable credential, and sending it back to the Credential Wallet. Okay, so you'll see the information that it's collecting now. I think it collects email address, liveness check, so a selfie, and some identity document scans, which we've blurred out. So you can see as well, you'll see my friend, the esteemed Mitch, our QA engineer. There he is. Hi Mitch. This looks like the sort of thing you're used to from other kind of information collection organizations, the Postident and that sort of thing. It does a similar thing, but importantly, the information here is now owned by you. You have a verifiable credential on your device that comes out of this, and the payment app that's kind of wrapped all this is only receiving select information. So what's happened at this point, or in a moment actually, once this step is done, the confirmation step, the Id Validator, who has been driving this entire process, is now generating a verifiable credential and sending it back to the user's device. And we've now passed the identity.com step, and now we're just in general onboarding of the app. The app has now received the information that it needs, and it's able to continue with the onboarding. Which means I can switch back to here. Don't worry, I'm not going to stay on this slide for long. I don't really enjoy UML diagrams, but I just want to kind of summarize what we just saw a little bit. So starting in the top left, the requester issued a presentation request to the Credential Wallet. This is from the view of the Credential Wallet, by the way. The Credential Wallet processes that presentation request and identifies that it does not have the credential needed to resolve it because you've just installed the app. So it goes to the marketplace, which finds the validator that can resolve it. That's another important point, by the way. I didn't make it clear at the start that the idea is that all of these things are pluggable. So there can be multiple validators. They issue different types of credentials. They all implement the Id Validator Toolkit in some way or another, either directly out of the box or in some modularized way. Once the Id Validator has been chosen, you start the credential request process, and that the Id Validator specifies to the client what information it needs and how to get it. This is the protocol part that I think is quite interesting in the Id Validator side of the triangle. I don't think we really have many protocols or standards for this stuff yet. It's quite a difficult thing. You don't want to tightly couple the device, which has a camera and has screens that you go through like you saw. You don't want to tightly couple that too much with the validator, who is saying things like, well, I need to see a passport now, or I need to have a validated email address. So trying to find a way of keeping the validator side flexible and independent from the Credential Wallet side or the app implementer side is what we're doing at identity.com, really. Anyway, you go through this process, and eventually it issues the credential and sends it back to the Credential Wallet. I'm probably going to stop on this slide and then see if anyone has any questions. And I'm available afterwards, by the way, because this idea of discovery is, I think, one of the crucial points here. There's a few different cases where discovery of information or kind of negotiating between the various layers of an identity ecosystem is quite important. I talked about one already where the presentation request doesn't map one-to-one to the credential that the user may have. Sometimes this is assumed that it's the case, and we find in the real world that it's not the case. Secondly, what validator can provide the information that I need to resolve a presentation request? And then validators themselves might have various different ways of collecting the information. So, okay, I will do one last slide. The Validator Toolkit looks like this, and you have various modules inside it. The idea behind the implementation of this was, or the architecture of this was, that any size validator, be an individual who wants to attest to the existence of their friend group, or a government that wants to convert all of its passports into verifiable credentials in a self-sovereign identity ecosystem, could use an equivalent ID Validator Toolkit. The modules themselves would look, at least some of the modules would look the same because they encapsulate the protocol, the app communicating with the validator, with the Validator Toolkit, but other ones will be completely different, how that information is collected and how it's validated. So you would, as a validator, implement this and then use some of the modules, replace some of the modules with your own, or you could use it out of the box. And I think I'll leave it there. Does anybody have any questions? Yeah.
A quick question about the marketplace, because it seemed to me that it's a rather centralized thing, but in just the previous slide,
Okay.
you did mention that it's a decentralized registry.
It is decentralized. So I will talk about the marketplace very briefly. So it has a number of roles, really. The first one is discovery of validators. We do this using anchored DIDs that are in, at the moment they're using Ether, so they're available on the Ethereum blockchain. That's one thing. Then once you have the validators, they can set their prices. We have a smart contract for this. At the moment, everything's on Ethereum. So they can set prices for the credentials that they offer. And I want to bear in mind here, you're not buying and selling information about users. You're buying and selling the attestations of that information, the validators having signed that information. The information itself, the proof of this is a Merkle tree. So there's no concept of personal information being stored on any public blockchain. It's really important. And then the final thing is that payment component. So when the requester, I didn't show a demo of this, but when the requester receives the information from the user, the validator gets a kickback. That's what gives the validator a reason for doing all this in the first place. They get paid by the requester. Again, it's a reusable identity sort of system. So if you generate a credential one time for one person, and they use that 100 times, you get paid 100 times. So it helps to make it, helps to incentivize validators to make the effort and to take the risk to validate an individual.
So I don't have to go through identity.com to reach the marketplace?
The marketplace is part of identity.com. But
the market through identity.com.
Oh, I see what you mean. It depends on how you describe identity.com. It's an ecosystem, so I don't know how you go there specifically. But I know what you mean. You don't have to log into a particular website centralized hosted by Civic or anything like that. No, it's a smart contract, and the source code is up on Ethereum and so on. Good question.
The Merkle hashes of the credentials are somewhere stored there.
I was trying not. It's a huge subject, so but so we have kind of three aspects of data that we store on the blockchain. The first is the DIDs of the validators. At the moment, we're the only validator, so that's just to ensure that it's possible, right? But the idea that other validators could come in and also register themselves there. So that's a public DID. The second is okay, I'll do the second one after the third one. The next one is the actual transactions of people buying and selling the attestations. So that's just a price and a kind of an ID, a unique ID that the validator knows and the requester knows. Sorry, actually the user knows and the requester knows, but nobody else has any clue what it is. There's no way of connecting it to any credential. And the third is what we call anchoring the credentials. And this is something that is related more to verifiable credentials and not so much to DIDs right now. But you take all the information in the credential, you generate a Merkle tree of it, and that Merkle root is stored in the blockchain. And that allows people to verify when they receive the credential that it is actually valid because it matches the entry in the blockchain. But again, it's a hash of multiple layers of hashes that can't be reversed.
Okay. Thank you.
Yep.
So maybe something that I just didn't understand so well. If we take the claim of over 18, it's supposed to be like self-sovereignty identity, right? So the way that I thought it would be is that I go to a validator, let's say Civic, I get a certificate from Civic that I'm over 18, and then I can use it without Civic knowing, Civic knowing, because the way that you presented, maybe I misunderstood, it always has to go through Civic and I have to pay something every time, and it's just not what I have in mind when you say self-sovereignty.
No, so the user doesn't pay anything at any point. And Civic is the validator in this case. We need to bootstrap the system somehow. And our plan is to get people using the system, and that will incentivize validators to join. That's kind of the first point. The second point about how you verify that a user is over 18, that's a predicate, right? That's a truth statement. The good thing about truth statements is that they can be encoded in zero-knowledge proofs. Now, not all of this is live right now, but the idea is the validator produces a credential, and that credential has a large amount of information in it. But each individual claim in that credential is itself verifiable on its own as part of the Merkle tree, and it's possible to generate zero-knowledge proofs to prove any predicates on that claim. So if you have a credential that's basically based off your passport or your ID card, it says the government, the state of Germany says that you were born on this date. That, if you give that information, you're already giving far too much information. You know that you've got German nationality and you know your birth date exactly. What you want to do, and the Credential Wallet is, in a later version will provide this feature, is generate a zero-knowledge proof so that all that the verifier knows is that you are over 18 and that this is somehow cryptographically guaranteed by the ecosystem. That part is purely between the requester, the verifier, and the user. That's important for self-sovereign. I think I've run out of time, have I? I've run out of time, but I'm around for more questions. I'm sorry.
Maybe one last question?
One last question?
Yeah.
Ah.
Yeah, just a small question.
Yeah,
Does
sure.
the verifier persistently store the personal information, and how is aligned with the GDPR requirements?
Yeah, that's a really interesting subject. So obviously once the requester or the verifier receives the information, it's out of the ecosystem. There's nothing we can do to prevent them from storing it. There's no self-destruct button on the data, unfortunately. There's a few things you can do. There's something called, we don't have this yet, but I'm really interested in it. There's a company called Ident3 that have this thing called non-reusable proofs. So basically this information is good for the requester only. And that I think is really interesting. And there's other, but basically the requesters in the real world right now, we're finding, often need to store regulatorily, for audit reasons, they need to store far more information than they want to store. They need to store far more information than they need for their business, just in case they get audited 5 years down the road. So they're collecting a lot more information than they should. And all we can do is rely on GDPR to prevent them from misusing that information. Once the information is, but one other last point, and I will finish there, is that with a self-sovereign identity solution, you specify exactly what information you're providing. So it shows up on the app, or the Credential Wallet tells the user, you are providing this information to this verifier. And that's already quite a lot more safety you get through a self-sovereign solution than you would have in many other kind of environments. If you log in with Facebook, for example, who knows what information Facebook is giving to the person that you're logging in with. Thanks, everyone.